Welcome to our next video. So today we're going to talk about different types of internal validity threats that we can identify and kind of be on the lookout for when we're evaluating different designs, especially experimental designs. My cat Truffles is here today with us, showing off her tail. Anyway, moving on. So I'm here in the notes where we kind of begin looking at different types of internal validity threats. So in our class, I kind of divided into 6 different categories. These are not like objective 6 categories that if you looked up internal validity on the internet, everyone's going to have the same 6 categories. This is just kind of how I choose to frame them in the class. It's a way that I think is helpful to divide them up. And when we think about internal validity, more so it's kind of a conversation starter when we talk about these different categories, because as we'll talk about, there might be kind of one threat or one thing that kind of hits multiple categories at the same time, right? So it's more that these are just kind of lens or perspectives into the conversation, kind of windows into the study that we can kind of systematically check and look through. So the first one that we have is instrumentation. So instrumentation just asks, is our means of measurement appropriate, reliable, and rigorous? So choosing a way to measure our response variable as well as administering the treatment factor is a careful and important choice, and there's not always a clear objective way to do so. Sometimes some studies lend themselves to more objective choices than others. Some studies, though, it's a very subjective choice how we do our instrumentation. So appropriate might be kind of this first category here, and that would just be, are we in the right category? Like, is the measure that we're choosing, does it make sense? So for measuring strength, then our instrument shouldn't just be measuring endurance. That's a very narrow measure of strength, right? So we should be measuring other things. We should probably argue that we should be pretty comprehensive about what we're measuring. But just in terms of appropriateness, the first question is, are we in the right category of thing that we're measuring? So as an example, like when you get into psychological studies, you see instrumentation's a really big deal. And creating good measures is not always very easy. So for example, measuring intelligence is a very difficult thing to do. Measuring IQ, there's a lot of debate about even like standardized test scores like the SAT or the GRE and what they're actually measuring. Are they actually measuring understanding and intelligence and critical thinking, or are they measuring other things? So if you're interested in that conversation, there's a link that might be interesting to you. But just in terms of this course, it's just a category that we want to be aware of. Our measurements should be reliable, so we should try to be doing the same things or the measurements in the same way for every unit, for every measurement that we're doing, that we want to be consistent, that we want as little human error as possible. So one thing I like to think about is like if there's, like using a stopwatch, I want to be as reliable and consistent as I can with measuring time if that's what I'm measuring. So there's all sorts of issues with just like, calibration and human error versus computer error and things like that. And then rigorous. So that just means that our instrumentation is comprehensive and complex enough to be helpful. So I'm not just taking really, narrow or really, vague, unspecific measurements, but I'm taking kind of specific and clear and comprehensive measures that can be helpful. So judging the rigor of our instrument and our instrumentation is a very complex thing to do. Like, you can literally get a doctorate in measurement and statistics, basically how to write good measures, how to understand how to measure things well in research. So we're just literally listing it as a category. We're not thinking that deeply about it. But we do want to be aware of, when this is a conversation, like when we evaluate a study, when this is worth considering as a possible validity threat, a possible weakness that plays into how we understand the results of the study. All right, so group selection would be another validity threat. And depending on how we sorted our groups, this may or may not be a concern. If we're randomly assigning people to our groups and we have a fairly large number of people, like I would say if we have at least 30 people per group, it's probably a very small concern if we have at least 50 or more people per group, it's very little concern. But if we're not randomly assigning or we have really small groups, there's always going to be a question of group selection. In other words, how balanced are the groups? For multi-group designs, it's definitely a question of how balanced. But we also have, if we're doing say like a pre-post design or something like that, we do have to be on the lookout for regression to the mean. And that's because if we are kind of identifying people into our study because they performed poorly or they performed really well on some kind of measure, and that's how we chose them into the study. So like, let's say that I found some people who scored pretty low on a math test. So I asked them to be part of a study, and I gave them all some kind of math intervention, some kind of, tutorial, math test taking tip, and they took the test again, and they all scored better, or on average they scored better. Well, I might just have a regression to the mean effect, meaning that if you take anybody, like any group of people who are the lowest test scorers, they are by chance more likely to score better the second time because you got them on their low scores. So because people tend to, what we say, regress to the mean. People tend to kind of balance out to the class average. So if I'm just picking people who happen to have a bad day, chances are they're going to do a little better the next time because they might be having less of a bad day. That would be kind of the underlying logic of regression to the mean. So we want to be careful of that too if we're doing a pre-post study. Where do the people come from, and is there a possible regression to the mean effect there if they're, extremely low or extremely high, and that's how they got recruited in. All right. The third validity threat that we're going to talk about is setting effects. And that would have to do with whether my groups are taking their interventions in different settings. So there's kind of a host of different categories, and we talked about this with the math bar example several times. But that would just be like, people are in different rooms, people are with different administrators, people have kind of different environmental factors that are interacting with each group, and they're not the same. So reactance would be one type of setting effect, and that would be that when people are being studied, they could act differently. So this is an internal validity threat in a pre-post study if I don't have a control group. So if I only have people who are in the study and I don't also have people in a control group who are also under study, then I have no idea if reactance is a confounding variable. Like, is it the reactance or is it the treatment itself that's causing the effect that I'm seeing? So reactance is a problem when I don't have a control group for comparison. A placebo effect we talked about, that is when I don't have a placebo in the control group to make comparisons with. So in other words, I don't know if it's people who are getting better from the treatment factor or from the idea of the treatment factor. In other words, they're just getting better, or they're just changing their actions because they know they're getting something, and they've been told it's a good thing, or they, just the act of having something done to you, whether it be an injection or a tablet or a session of some type, makes you think that you're better, or that you're different. So a placebo effect is a problem, again, if I don't have a control group that also has some type of intervention to mimic that psychological effect. So you always want to be careful that studies are going to be stronger if you have that comparison group such that you are minimizing those types of differences, and that it really is the intervention and not just the act of the intervention or the experience of being in the study itself that are making this difference. Researcher effects would be if the administrators know what's going on and they're acting differently, and thus may be affecting the participants even subconsciously. So that's where double blinding comes in. If you don't have double blinding, you might have a researcher effect if you have researchers or administrators interacting with the participants who know who is in which group and might be acting differently. So if you have double blinding, or you don't have administrators interacting with the participants in the study, then this isn't a problem, right? But if one of those things is true, like if if both of those things are true, if the administrators are interacting with participants and they know who's in which study, that could affect how they interact with them, and that could affect the results. And then just in general, other environmental condition differences. Like I said, different rooms, different temperatures, things like that could affect people's experiences beyond the intervention itself. Time effects would be a fourth category, and that would be if my groups are doing their interventions at actual different times, and whether that might be a factor. So history would be like this idea of, the people, I have two groups, but they're doing it on different days or in different weather, in different seasons, with different current events, or different times of the day even. Could that play into this? Could that affect the results and confound my comparison? In other words, time is confounding the difference. Like time is different between these two groups in addition to the intervention itself. So this can certainly play into effect, like if we consider the math bar example again. What if one group took their test at 8 a.m. and one group took their test at 1 p.m.? Time could be a factor. People might do differently on tests depending on what time of day they're being tested. I don't actually know if that's true, honestly, but it's a threat. It's a thing that I have to recognize that could possibly confound this result. So yeah, history would just be this idea of different timing effects for my groups. If you're doing a pre-post study, then you have to think about maturation. And that would be that people are just growing up and they're just having different experiences alongside the treatment factor. So that's kind of one reason why pre-post designs have a lot of weakness and they have a lot of questions, is because depending on how much time is passing, the participants might be having a lot of other experiences besides the treatment factor that are affecting the response, that are affecting the results. It could be like literally you're just growing up and maturing, like the word suggests, or it could just be that you're having other experiences, other things that are happening. So the key to identifying these is just systematic bias, right? So is there something different between my control groups and my treatment groups? Or in the case of like a pre-post study, are there other things going on besides the treatment factor itself that could be influencing those results with respect to time? All right. Mortality would be a fifth category. And this one's a little bit tricky because you might be tempted to think it's a validity threat a lot of times when it really isn't. So we need to clarify when this actually matters. But it has to do with the fact that people will drop out of studies. It might be because of death. It might be because they just don't come back. It might be because they're just not adhering to the study procedures, their intervention procedures. But for all these reasons, we kind of lose people in experiments, in studies, and that could influence our comparison. We'll talk about when it does. So this is really a threat when people are dropping out, typically in different rates between our groups. So let's say that we have a handful of people drop out of the treatment group and a handful of people drop out of the control group, and I have reasons to think they're dropping out for similar reasons. That's not really a mortality threat, right? Because they, that's not necessarily affecting the group balance that I'm left with at the end, because I'm probably losing the same types of people at the same rates. However, if people are dropping out for very different reasons, like maybe people are dropping out of the treatment group because it's too hard, like it's too much, or people are dropping out of the control group because they're bored or they don't care or they don't think they're getting anything from it or whatever. That those are different reasons, and that could be something that's systematically affecting my results. And certainly, if people are dropping out in different rates between the groups, that's definitely a red flag that maybe there is a systematic difference between people's experiences and why they're dropping out, especially if they're dropping out in different numbers and we're actually getting to a significant number, like a significant proportion of my participants are just not finishing. So whenever that happens, I should be concerned because who I'm left with may no longer be equal, and therefore I may no longer have an apples to apples comparison with the final results. Yeah, and so death is really kind of the same category, but it's just this idea that people drop out of the study, and depending on how many people drop out, this can be a problem. Certainly, this does apply to a pre-post study as well. If I have a lot of people drop out, so it could be that people are dropping out because this is not working for them, and the people who are staying in are the ones who it is working for them, and then I might be left with this result of like, oh look, like 60 out of 65 people had a positive experience and they had good results and they improved. But I also had like 40 people who dropped out of the study, and a lot of them dropped out because they weren't getting better. Well, that's a problem, right? So that needs to be taken into consideration. That would be a validity threat to my final result there that I need to report as a limitation. So yeah. The last category of validity threats is test familiarity, and this is specific to pre-post designs, and I'd also say somewhat to crossover designs. Crossover has some other things built in, so that like if I have a treatment group and a control group and then they switch, well technically I do have kind of the first measurement from both, one from treatment and one control that I can compare, kind of like a randomized controlled experiment. So to some degree that is not an issue. But whenever I have people taking the same measure more than once, whether it be an identical measure or whether it be a super similar measure, I might have a test familiarity threat to keep in mind. In other words, people might just be getting better at the measure. Like they might just kind of, essentially practice on the first one where like the first one is the first time they've seen it, but the second time they might be more comfortable doing it again, or they might just do better at it because they've seen it before. So we have to keep that in mind whenever we have people taking the same measure more than once. This is especially the case for cognitive or even physically related tests where there is going to be some kind of improvement just from practice. Now, some things, like I would say, I just want to clarify this. So I should probably say, or crossover designs. Lingering effects, though, is definitely a crossover-specific issue as well. So I just want to clarify that there. I do want to mention, though, let's say that I'm measuring something like blood levels, like I'm taking a blood sample from someone, I'm doing it before and after an intervention. Well, that's not really going to have a test familiarity threat because I'm probably not going to get better at taking blood the second time, right? Like, I don't think my body is just like, oh, I'm so comfortable, so I'm going to give you a better sample of blood today. I don't think my body does that. So it does depend on the nature of the measure being taken, right? So just because I have a measure taken twice doesn't mean there's a test familiarity threat. It's going to be something that I see whenever there's a cognitive element or like a kind of a physical element in terms of like, coordination or something like that, then it's certainly on the table. All right, so then we have a practice example down here where we have an experiment, and we're going to talk about some internal validity threats. And I say it's an experiment. I actually think we could call this an observational study depending on what lens you want to take. But either way, we have a study, and we're interested in a possible causal relationship, and we're going to think through all the different internal validity threats that could apply to this setup. So here we have an educational researcher, and she is wondering whether her students learn better in a traditional classroom setup or a flipped classroom setup. And I feel like given the nature of the times that I'm recording this video, I almost want to say like an online class would be my interest, is like, student performance in a traditional in-person meeting class versus a fully videoed class. I think that'd be kind of interesting. Either way, we'll just go with the prompt as it is. So what she does is she has a traditional class set up in the fall semester with 74 students, and she does the same course again in the spring with 89 different students. She wants to know if both sets of students have approximately equal academic success, or if there might be a difference here. So she gives both classes the same exam at the beginning of the semester, and again at the end to see which class has improved the most. Okay, so she has an assessment. Everyone's taking it at the beginning and at the end of the semester. But then I also have, another class over here with the other style, with the other setup, and they're also taking it at the beginning and the end of the semester. And then I'm going to see who has the most improvement, or if there is a difference in improvement at all. So let's think through what are some possible internal validity threats that we should consider here about this causal relationship between the style of the instruction and the academic success. Is the style of the instruction the only thing that's different between these two setups, or are there other possible confounding issues? The first one I'd bring up is instrumentation. Not because there's a clear red flag, but because we just have to ask the question, what is this exam? Do we know that this is a good measure of what you're studying? And is it well designed? So anytime we're working with some kind of a cognitive measure or something like that, we should really always think about instrumentation. How do we know that this is kind of a validated assessment and that's measuring what we think it's measuring? And I'm just going to kind of put here as a note, always ask about cognitive measures. Things that I would want to know are like, was this measure validated by experts? Has this been used before and tested before? So it's not just any old set of questions that you pulled up, but something that you're actually confident about is measuring what you want. The second thing that I'm going to note here is group selection. And this is where we kind of get into this question of, is this an experiment or an observational study? I think this is probably better described as an observational study because we don't really have the power of assignment. In this example, it sounds like students are just kind of choosing into their own classes. Like at best, it's a non-randomized controlled experiment where I suppose we have some control over the intervention, sort of, loosely. But we don't have any power over assignment, though. So I would say for that reason, I consider it more of an observational study. And we definitely have a group selection threat on the table here. And that's because we don't really have any way of knowing from this information if these are balanced groups of students. So something that I would mention here is we might have different types of students who take the class in the fall versus the spring. You might also have like a freshman effect, right? So like first semester freshmen. If it's your first semester in college, you're going to be a very different type of student than you will be your second semester of college. So if it's a freshman level class, this is definitely on the table. Even still, I've taught classes before, and I've noticed that, like, for example, I taught an education class where we got a lot of education majors who took it in the fall and a lot of education minors who took it in the spring. And there's a very, very different vibe between those sets of students in my experience that year. All right, so I think the next category that we have on our list is setting. And so I think setting is kind of hard to know from this, right? So like, is there a difference in like the classroom, or the students know they're being studied and things like that? And it's information that we don't really know. So I would say that's kind of a more debatable point that we want to bring up is, is there a possible placebo effect with students knowing that they're in that they're in a study and what they know about which one the teacher prefers and things like that. Something I might mention, I'll mention setting, and I'll mention researcher effect. I think that would totally be relevant here. That the instructor might teach differently depending on the mode of instruction based on which one she thinks might be better. It might tempt her to care a little bit more and to go a little bit the extra mile, say in the flipped classroom environment, if that's the one that she believes in more. Four, time effects is absolutely a possibility here because we have seasonal differences, current event differences. these are two completely different time periods. And so that could totally play into effect. For example, snow days, weather, light, mood, things like that, activities. That can totally play a role. Seniors who are getting lazy and want to just graduate in spring semester, totally a thing that could affect class progress. So it's a question to ask. It doesn't necessarily mean it's definitely confounding, but it's something that we want to ask about. Okay, and I'm at the point where I probably need to move my camera. I'm going to go up here. Okay. Let's see. So the other things we have are mortality. So mortality could play a role if we're thinking about people dropping out of the study. I guess I didn't say mortality, but dropping out. And this would be an issue if people are dropping out at different rates or for different reasons. So if I have a couple of students dropping out of both semesters, I probably don't care that much about this. But if I have a lot more students dropping out of one than the other, or if I get the sense that students are dropping out for different reasons, maybe because one of these is really hard or one of them is really boring, right? That would be different reasons. If there's a difference, in rates or reasons, this would be relevant. The last one is a test familiarity threat. And this is technically at play. Now, in this case, it's very minor. And I say it's minor because I don't just have one class taking a before and after test. I have both classes doing a before and after. So I can kind of measure the effect, like the change in score from these tests. And so it's probably okay if people are getting a little bit better at it, because I can kind of parse out the test familiarity bump, the test familiarity improvement by comparing both classes. So this is mostly irrelevant, I would say. It's okay to note it, but again, like it's because I have two groups and both of them are doing a before and after test and I'm comparing the difference, it more or less just washes out as an internal validity threat. I would also know that there's things that we can do to check some of these. So for example, instrumentation, we wrote it down as a question to ask. It might be that this is a validated instrument, or we could use a validated instrument, so it's not necessarily an issue. Group selection. Again, there's things that we could do. Like, I would say that if we have these pre-tests, if we have these tests at the beginning of the semester, I want to know if students are scoring about the same on average in both semesters. Because if they are, that might suggest that I really don't have a big group selection threat. So as long as I'm getting equivalent pre-measure scores or pre-semester scores from both groups, then I can kind of eliminate group selection as a real problem. Setting, again, like, there's things that the teacher can do. It's still on the table, but it's something that can certainly be minimized if the teacher is aware of this. Again, like uses the same classroom or uses the same environment as much as possible. However, time effects is probably one thing we really can't eliminate. I think that's going to be a pretty constant in this design, is that the teacher just has to have two separate semesters. Perhaps having both being in fall might be an improvement, maybe. Again, like there's still going to be a current event difference, but maybe having it during the same semester, like the same fall, is a good idea. But yeah, I think it's kind of hard to completely eliminate time effects without just having them both run the same semester. But yeah, I hope that was helpful. Just kind of thinking about a real world example and talking about which of these would apply and to what extent it might apply.